Hey everyone, I just want to go ahead and show you a few examples of how to graph some logs. All right, so we're going to start with some basic rules that generally apply for most every one of these functions. We're going to go ahead and start by graphing the asymptote, and you can see kind of I already put it in there. Remember, your asymptote is your h value, so in this case it's x equals 1. We're going to go ahead and start at your initial value, which is your 1, 0. And even though there's a number 3 in front of here, we're still going to start at that point 1, 0, and then we're going to shift it. The 3 comes into play later when we talk about, like, it's basically going to scale your function up a little bit, and I'll show you how that works. We're then going to find a couple other points by putting the numbers into our table. We're going to plot them and graph. All right, so we have our initial value. I'm going to go ahead and do our transformations. So this means I'm going to move to the right 1 and up 2. And so if I do that, this point here is called our translated intercept. And what that point is the point 2, 2. So in my table, I'm going to show you how I got that point 2, 2 algebraically. All you can do is if you plug 2 in for x, you would get 3 log of 2 minus 1, which is 1, plus 2. If you don't remember, log of 1 is just basically is 0. So log of 1 is 0. Now if you don't remember that, you can always go to your calculator. Move out of here. And you can just hit the log button since there is no base, which means it's a common log or a log with a base of 10. Log of 1, and you would see that you get 0. So 3 times 0 is 0. 0 plus 2 gives me 2, which is how I got that point there. All right, let's do some others. Let's plug in, well, let's not do 1. Let's do 3. So 1, so we plugged in 2, let's try 3. So if I plug in 3, I get 3 log of 3 minus 1 would give me 2 plus 2. All right, so I'm going to grab my calculator, and I'm going to go ahead and type this in. So 3 log of 2, close your parenthesis, plus 2. So I get about 2.9. That's what I'm going to round it to at least. So when I have a x value of 3, I get a y value of about 2.9. So maybe right about there. And then for the last point, I'm just going to use 4. So 3 log 4 minus 1 would be 3. And again, grab my calculator. So 3 log of 3, close the parenthesis, plus 2. I get about 3.4. So 3.4. So when x is 4, so 1, 2, 3, 4, I get about 3.4. So 1, 2, 3, so about right there. So you can kind of see, you obviously know where the asymptote is. Remember what the shape of a log function looks like. It needs to approach your asymptote, and it has kind of that curve. And that's kind of your basic log-looking graph. All right, let's graph a couple others. All right, so this one has a log with a base of 4. If you notice, this has a horizontal stretch. Actually, it's a horizontal shrink by a factor of 1/2. So the first thing I'm going to do is go ahead and plot my asymptote. There is no h value here, so my asymptote is going to stay right here at 0. I'm going to go ahead and plot my initial value, which is at 1, 0, and apply any shifts. Now, this one is a little different because of the fact that we have that 2 in there. It kind of throws off my initial value. So I'm going to go back right now to my table, and I'm just going to start plugging in some points. So I know that I'm dealing with something when, like, x is 1. So that's kind of what I'm going for here. So if I plug this in, 2 times 1 is 2. So what's log base 4 of 2? Well, I don't really know what that is. So what we're going to do is we're going to go to our calculator. So I'm going to clear this out of here. In order to get the base of 4, so it's not your common log, so it's not this log right here on your calculator, you have to kind of use a couple different things. You could use that change of base formula that was taught in a previous lesson, or you probably also learned that you can hit the math button. And if you arrow up a couple times, you should see something like log base. It might be a little different on your calculator, but something similar to that. And what you get is a template for your log. So I'm just going to fill in the blanks. I'm going to put a 4 in there, and I'm going to put a 2 in here. So when I do that, log base 4 of 2, I get a half. So this point, this translated intercept, because of this 2, it's a little different. So we have to do this a little bit differently. So this is at the point 1 and then a half. So roughly about right there. Okay, let's try a couple other points. Let's plug in 2. So I get log base 4 of 2 times 2, which is 4. Anyone know what log base 4 of 4 is? In case you don't know, you can go to math, arrow up, and do 4. Should give me 1. Voila. So at the point 2, 1, I'm going to plot that point. Next, I am going to use the point 3. So log base 4 of, when x is 3, this is log base 4 of 6. So I am going to, again, go back to my calculator. Log base 4 of 6. It's not really clear. Okay, there we go. I get about 1.29. So when x is 3, I get about 1.29. So this is a kind of a really slow looking graph. If you wouldn't know any different, you would think that maybe this looks linear, but of course you guys are all super smart and you know it's not. So it has to have that curve shaped graph, and that's what it's going to look like. All right, last one we're going to talk about. This one has a negative right here, which remember, if you remember, is a reflection. But this time it's a reflection over the y, so in the y-axis. This is also going to shift my graph up 1. So a reflection in the y-axis and a shift of up 1. All right, let's start with the asymptote. So if you notice the asymptote, the h value is, there isn't an h value, so it's 0. So it's going to be right here on the y-axis. I'm going to go ahead and start with my initial value, which in this case is 1. I think what I'm going to do on this one, because of, again, this negative in here, it's going to cause my graph to kind of, I don't know, do some funky things. So I'm going to go ahead and I'm going to plug in, I know what, if I have, like, for example, if I have my initial value is 1, if I'm going to reflect it over the y-axis, I'm actually going to use the point -1. Right? So if I start here with my kind of my initial value, right, I'm going to shift it up 1. I'm going to shift it up 1 and over 1. And the reason why I'm shifting it over there is because that's that reflection. So I shifted it up 1 because of this k value, and then I reflected it over the axis because of, because of this negative right here. So if I'm going to go to my table, and you can show on your calculator how this works, I should be getting that translated intercept should be at the point when x is -1. And again, you could do this without kind of going through that process, but let's see how this looks. All right, so this would be natural log. Oh, it's here, let me put it in here. So I get natural log. If I plug in -1, this would be -1, or in other words, 1. So natural log of 1 plus 1. So remember, your natural log button's down here, right here, kind of next to the 4. So natural log of 1, close your parenthesis, plus 1. I get an answer of 1. Remember, that's kind of what we expected. So when x was -1, we got a y value of 1. All right, next, let's try, you know you're not going to pick x values this way because you're going to run into your asymptote. So we need to go this direction. So I'm going to pick another x value of like -2. So if I do that, I get natural log of -2, which is 2. And I'm going to grab my calculator, and I'm going to do natural log of 2 plus 1, and I get about 1.7. So when x is -2, y is about 1.7, so roughly right there. One more point. Natural log, this would give me 3. Go to my calculator, and I get about 2.1. So when x is -3, I get about 2.1, which is, again, very small. Kind of, again, it looks almost linear. If you remember, it's approaching this asymptote, which kind of messed up there. It's approaching the asymptote with a curve. It should look like that. So this is that reflection over the y-axis It was shifted up 1, but it's definitely a different looking graph. And we had to use our calculator to get those values. All right, practice graphing some log functions. Practice with your transformations. If you have questions, log into the office hours. Thanks, everyone.